Let's look at a two-tailed z-hypothesis test for a proportion. 2 years ago, 78% of students in high schools in Kenton County were considered proficient based on standardized testing requirements. A parent wants to determine if a change occurred last year in the proficiency level of all Kenton County high school students. In a random sample of 500 students from Kenton County, it's found that 372 were labeled proficient last year. Using a 5% level of significance, has a change occurred in the proportion of proficient high school students in the county? Begin by defining your parameter. So the parameter P represents the proportion of all Kenton County high school students who were proficient last year. Next, the null hypothesis H0 is that the parameter P equals the value of 0.78 for the proportion from 2 years ago. The alternative hypothesis HA is that the parameter P is different than 0.78 or not equal to 0.78. Notice this might imply the value is smaller, or it might imply the value is larger. So values in either the left tail of the distribution or the right tail of the distribution suggest a change has occurred. We will use this to calculate the p-value later, but keep in mind we're making the decision now at the point we are stating the alternative hypothesis to check the chance that a sample would be as far away from the mean, the 0.78 value for the proportion, in either direction, to the left or to the right, when we find the probability or the p-value. We let alpha equal 0.05, so the decision rule is as follows. If the p-value is less than or equal to 0.05, then reject the null hypothesis. Is this valid? A random sample was taken and the collected data is categorical. Are the students proficient or not? N times P is 500 times 0.78, which equals 390 successes that are expected, and that does meet the at least 10 requirement. And N times 1 minus P equals 500 times 0.22, which equals 110 failures expected, and that also meets the at least 10 requirement. So the one sample z-test for a proportion is appropriate. Next is the test statistic. Now remember, the test statistic is the z-score calculated as p hat minus p in the numerator with the square root of p times 1 minus p over n in the denominator. You can see where all the values are plugged into the equation and then see that this leads to eventually getting a z-score of negative 1.94. So what we would do is sketch our standard normal curve, label the negative 1.94 both as a negative and a positive value. Now the p-value is where we go back and see the alternative hypothesis said not equal to for the inequality. So we agreed at that point to look to the left of the negative absolute value of the z-score and to the right of the positive absolute value of the z-score to get the overall chance of being 1.94 or more standard deviations from the mean, okay, or from a mean of 0 in the z-curve in either direction. So we find the area in the left tail and the right tail. This is the same as doubling the probability the z-score is just smaller than the absolute value multiplied by negative 1 to force it into the left tail. Or you could find the area on the right, but that involves taking the table value and subtracting from 1. Either way, the area in the left and right tails are 0.0262, so doubling those or adding them together, you get a final probability or p-value of 0.0524. Now apply your decision rule. Is the p-value 0.0524 less than or equal to 0.05? No, it's not, so the decision is fail to reject the null hypothesis. Finally, you want to write your summary sentence. At a 0.05 level of significance, there is not significant evidence that the percentage of all students in high schools in Kenton County who were considered proficient based on standardized testing requirements last year is different than 78%.